Hello students, welcome to the lecture on energy conservation and management, and after this lecture we will be able to learn the following objectives. Understand energy saving buildings, explain energy efficiency in architecture, an overview of design concepts and architectural intervention. Describe the importance of energy efficiency in buildings, define electricity pricing and market access, discuss on control for energy efficient buildings, explain the food and beverage production, define energy management challenges in the hospitality industry, explain energy conservation in India. Let's start with the concept of energy conservation and management. Energy is a driver of growth. International studies on human development indicate that India needs much larger per capita energy consumption to provide better living conditions to its citizens. But such growth has to be balanced and sustainable. Two important concepts here are energy management and conservation. Planning Commission of India has estimated that India has conservation potential at 23% of the total commercial energy generated in the country. India's energy requirement comes from 5 sectors: agriculture, industry, transport, services and domestic, each having considerable saving potential. With economic growth and growing prosperity, the energy demands in India are rising. The country is now faced with the challenge of meeting growing energy needs to sustain its economic growth while dealing with the global threat of climate change in various booming economic sectors such as retail, hotel, industry, business and information technology. New buildings are being constructed. They require a large amount of energy to operate, example for air conditioning. Let us now discuss the energy efficiency in architecture and overview of design concepts and architectural interventions. Buildings as they are designed and used today contribute to serious environmental problems because of excessive consumption of energy and other natural resources. The close connection between energy use in buildings and environmental damage arises because energy-intensive solutions sought to construct a building and meet its demands for heating, cooling, ventilation and lighting cause severe depletion of invaluable environmental resources. However, buildings can be designed to meet occupants' need for thermal and visual comfort at reduced levels, energy and resources consumption. Energy resource efficiency in new construction can be affected by adopting an integrated approach to building design. The primary steps in this approach would be to incorporate solar passive techniques in a building design to minimize load on conventional system, heating, cooling, ventilation and lighting. Passive system provide thermal and visual comfort by using natural energy sources and sinks, example solar radiation, outside air sky, wet surfaces, vegetation, internal gales, etc. Design energy efficient lighting and HVAC system, heating, ventilation and air conditioning. Once the passive solar architecture concepts are applied to a design, the load on conventional system, HVAC and lighting is reduced. Further, energy conservation is possible by judicious design of the artificial lighting and HVAC system using energy efficient equipment, controls and operation strategies. Use renewable energy system, solar photovoltaic system, solar water heating system to meet a part of building load. The pressure on the earth's non-renewable resources can be alleviated by judicious use of earth's renewable resources, that is solar energy. Use solar energy for meeting electrical needs for a building can further reduce consumption of conventional forms of energy. Use low energy materials and methods of construction and reduce transportation energy. An architect also should aim at efficient structural design, reduction of use of high energy building material, glass, steel, etc. and transportation energy and use of low energy buildings material. Now moving on to the next topic, we will study the importance of energy efficiency in buildings. Rapidly increasing energy prices, concerns about resource depletion and climate change and calls for national energy self-sufficiency have concentrated people's mind on the role energy plays in our lives. Much of the effort is focused on securing sufficient supplies of oil, gas, etc. at affordable prices, but reducing energy demand at source can be a better alternative. Rural India is more dependent on traditional biofuels. On average, 55% of households in India have access to electricity, this figure falling to 43.5% for rural areas. The construction industry is booming and is one of the largest energy-consuming sectors in India. Even a 10% reduction in energy use in building would have a significant impact on national energy requirements, and this could be achieved with little or no investment, simply by being more diligent in our use of energy in homes and offices. Energy use in existing buildings. Since we replace old buildings with new ones only at a very slow rate, it is important to consider how we use energy in the buildings already there. The first step in an energy efficiency approach is to find out where is the building most energy used. An energy audit will pinpoint those areas and enables the most effective measures for cutting the energy cost to be identified. It is estimated that buildings could save 10 to 15% on the energy bills by implementing energy efficiency improvements, which not only make the environment more comfortable, but can also yield long-term financial rewards. The thermostat should not be set at a colder setting than normal when the air conditioner is switched on. It will not cool the home any faster and could result in excessive cooling and therefore unnecessary expense. The smaller the difference between the indoor and outdoor temperature, the lower the overall cooling bill. By allowing the temperature to drift upward slightly by a degree or so, a substantial amount of energy can be saved. Also, windows and openings should be closed when using air conditioning, as there is little point in using energy to cool the air than allowing a large amount of warm air into the building. Location of a temperature sensor should be such that it senses the temperature experienced by the occupants and or can therefore control the environment to the desired level. Building design and plan for new buildings. An energy efficient system for commercial buildings such as offices and hotels is one that meets the primary needs and provides necessary indoor thermal climate and air quality while consuming the least amount of energy in terms of indoor thermal environment. Main problem in buildings in India is to keep them cool, not warm. Lighting can use a surprising amount of energy, particularly if blinds are drawn to reduce solar excess. Lighting needs and use patterns need to be studied, paying special attention to high-use areas such as the living room, kitchen, and outside lighting in a house, therefore replacing standard light bulbs and fixtures with compact fluorescent lamps (CFLs) and using lighting controls such as occupancy sensor, dimmers or timers will help to reduce lighting energy use. Exterior lighting is one of the best places to use CFLs because of their long life. Let's know the meaning of electricity pricing and market. Implementing more cost-reflective electricity prices when a large part of the population lacks access to electricity is a difficult task. Reforms need to benefit a large majority of the population in order to be accepted. The fact that about 1/3 of India's population lives below the poverty line raises the question of the initial cost of providing access to energy markets. Hence, as in many other developing countries, subsidies are likely to remain a key part of pro-poor energy policies for some time. Traditional ways to deliver subsidies often fail to help the poor. The challenge for government is to find better ways of delivering subsidies. Healthy competition in the energy sector will eventually bring down costs and assist capital formation. In the short run, however, the consumer price will increase to reflect the cost of providing energy service. Without subsidies in a country like India, there would be two negative effects of pricing energy at cost. Some consumers who are not able to pay the price may lose access to commercial energy. Energy pricing should aim at cost recovery. But in a situation where energy is likely to be under-provided by the market, the need for some form of support to promote access to the energy service for poor households is acknowledged. However, the budgetary costs of subsidies are high. Financial support needs to be targeted and limited by time or income to avoid the regressive effects of subsidizing energy users who are able to pay. The cost may be paid through a system of gross subsidization or directly by the state, if public finances permit. Latter is preferable. The cost of a subsidy ought to be clearly identifiable. The cost of a subsidy ought to be clearly identifiable. The cost of cross subsidies might be hard to identify. A subsidy scheme should have minimal implementation costs. In this respect, a system providing the subsidy at the supply level, such as in India, has one advantage. Its administrative costs will probably be lower than a system providing financial support directly to the demand side through vouchers or income support schemes. Direct support for demand, with the subsidy going to the consumer to cover the cost of his connection and or consumption, would be more efficient and cost effective but more expensive to administer. It would be required clear rules to identify and transfer the financial support to the beneficiaries. Various options exist for excluding unwanted beneficiaries. Each of them has different budget implication. Apart from a general underpricing of electricity as practiced in India, ad hoc subsidy schemes have been established by private investors and public utilities in developing countries at the request of local administrations or in response to populist political pressures. The building sector is responsible for about 40% of energy consumption and more than 40% of greenhouse gas emission, hence the interest in increasing energy efficiency in buildings. Heating, ventilation, and air conditioning (HVAC) is a principal building system of interest, but there are others: lighting, active facade system, renewable generation sources, and storage. Real-time control and optimization can help building owners and tenants minimize energy consumption and cost based on inputs from occupants, local utilities, and weather condition. Challenges for implementation of advanced control solution include the heterogeneity and complexity of typical building environments. New developments in building models and in building automation system are addressing these and other challenges. Buildings as systems of systems. Buildings are complex systems composed of subsystems that were traditionally deployed independently of each other. This applies not only to building energy systems but also to other systems such as access control, fire protection, and video surveillance. Heterogeneity. Building components do not necessarily have mathematically similar structures and may involve different scales in time or space. For instance, building control is a complex hybrid problem that includes both continuous and discrete components. Major building systems operate in discrete modes: air handlers or cycle on or off, silo compressors. Complex relationship. Building components can be connected in a variety of ways, which may cause complicated dependencies between local and system-wide phenomena. The HVAC systems are potentially very large network systems with complex relationship between the comfort in rooms or zones and operation of individual HVAC components. Challenges and opportunities in energy-efficient buildings. Entropy is the perpetual enemy of building operation. Building systems degrade over time, and today little can be done about it. Historical operational data is difficult to gather from building management systems. Accurate models are generally not available and are hard to develop, and the availability of skilled staff is limited. Recent developments are helping overcome this difficulty with building information models (BIMs). Standardized way to describe aspects of buildings has become available. Most medium to large buildings now routinely capture large quantities of operational data, and energy efficiency and load management have become high priority imperatives. Performance monitoring and health management. Physical and control system faults in HVAC system cause inefficient operation, increase energy use, and reduce equipment life. Many of these problems could be prevented with widespread adoption of automated performance monitoring and equipment health management. The uniqueness of most HVAC implementation, lack of design information, and limited sensor for monitoring has been obstacles that are in the process of being overcome. The importance of energy saving in the hospitality industry. Energy saving is a topic that has been at the forefront of conversations around the world for the past few years. Whether it is a global warming debate or the latest in hybrid autos, it is all about energy. For the hospitality industry, energy saving has a special role. Saving energy helps the planet, sure, but it also has a very positive effect on both bottom line and the positive way in which guests view property. Many guests prefer to stay at energy-friendly properties versus those that are not able to demonstrate and promote their green status. Environmental issues in food and beverage proceedings facilities primarily include the following: solid waste, wastewater. Solid waste. Depending on the raw materials, food and beverage proceeding activities may generate significant volumes of organic perishable solid waste in the form of inedible materials and rejected products from sorting, grading, and other production processes. Where meat products are the raw material, solid waste may have the potential to significantly impact food safety due to the proliferation of harmful bacteria and other organisms. Wastewater. Wastewater, typically organic waste, chemicals and detergent used in various processes including cleaning. In addition, effluent may contain pathogenic bacteria, pesticide residues, suspended and dissolved solids such as fibers and salt particles, nutrients and microbes, and variable pH.
This is a very basic overview of the water treatment process. Customers always need water, but rainfall is seasonal and increasingly unpredictable. So we often use storage reservoirs to make sure there's always a supply for treatment. By passing water through mesh screens, we remove sticks, water weeds and other large foreign objects. The air takes some odours and gas from the water and allows some dissolved metal salts to separate to be filtered out. We add air by cascading the water down a tower, spraying it into the air or bubbling air through it. At this stage, there are still some fine pieces of matter suspended in the water, along with colour and bacteria. We add a precisely controlled amount of a coagulant like ferric or aluminium sulfate. This reacts with the material in water, making it all stick together to form what's known as floc. To make this flocculation happen, water and the coagulant have to be mixed together very quickly and thoroughly in a special device called a flash mixer. Next comes the clarification process. The floc forms itself into sludge and is separated in a specially designed tank called a clarifier. This sludge layer is called the sludge blanket. To control the blanket, sludge is periodically drained off, concentrated and removed for safe disposal. Particles filtered out on the RGF, the rapid gravity filter, are removed by backwashing. The water now needs filtration to get rid of any remaining particles. Water is filtered slowly through very fine sand or sand-like material. For some river waters, we use ozone gas injection as a treatment stage. This can work in conjunction with GAC or granular activated carbon treatment, where the water is filtered through carbon granules to take out any undesirable traces of largely natural organic materials. The carbon in these filters is removed and regenerated by heat so it can be used again. Now the water's filtered and thoroughly cleaned, it's disinfected to make sure no harmful bacteria remain. A small, controlled amount of chlorine is the most effective method and provides essential customer protection. This method is used across most of the world. The chlorine has to stay in contact with the water for a period of time for effective disinfection. Last but not least, adjustments are made to the pH levels of the water during the treatment process so that it's neither too acid or alkaline. This helps pipework, fittings and the water itself. From the treatment works, water is fed into a huge mains pipe network, nearly 43,000 kilometres long, which forms a grid around the region. This grid is then accessed directly to your home, and when you turn your tap on, it's available to you. Clean, safe drinking water.
The Electric Power Research Institute explosion that energy and energy-related costs represent INR 40,000 billion in annual expenditure. Commercial buildings constitute the most electric-intensive sector in the country, with 76% of the energy services provided by electricity. It is estimated there are 4.7 million commercial buildings which consume 35% of the nation's total electricity. Energy costs associated with heating, ventilation and air conditioning (HVAC) add up to one of the largest operating expenses for property owners. In most companies, the cost of energy is the largest unmanaged line item operating expense. With electricity rates skyrocketing, being able to control a building's energy usage represents a huge savings opportunity. Many utilities have raised their rates more than 70% over the last 2 years and in some cases cost more than doubled. With rising fuel costs, rates are forecast to continue in this direction. Components. To manage and monitor the amount of energy used to heat and cool commercial buildings, the following components are needed. Packaged Terminal Air Conditioning (PTAC), central air conditioning or package units, A PTAC is a self-contained air conditioning unit and may incorporate either a heat pump or electrical resistant heating, occupancy sensor, motion detectors, CO2 sensor, air quality sensor and door switches. These are used to determine whether or not a space is occupied. Intelligent, programmable thermostat. These interface with occupancy sensor, motion detectors and door switches to monitor a room's temperature. A controller communicates with these devices to adjust the temperature settings and dynamic setbacks depending on current and future needs for the space. Intelligent power meters or submeters. These provide a detailed energy profile of buildings, campuses and full enterprises. Challenges. There are many diverse challenges when implementing an energy management solution. Companies need to be familiar with all the available utility rate structures to be able to lower their utility bills. They may be overpaying for electricity because of incorrect rate clause, inefficient building system or less than ideal occupant electricity usage patterns. India has made rapid stride towards economic self-reliance over the last few years. Impressive progress has been made in the fields of industry, agriculture, communication, transport and other sectors necessitating growing consumption of energy for developmental and economic activities. If India is to achieve the targeted growth in GDP, it would need commensurate input of energy, mainly commercial energy in the form of coal, oil, gas and electricity. However, India's fossil fuel reserves are limited. Energy demand and supply. On the energy demand and supply side, India is facing severe shortages. 70% of the total petroleum product demand is being met by imports, imposing a heavy burden of foreign exchange. Country is also facing peak power and average energy shortages of 12% and 7% respectively.
The key drivers of energy demand is population growth and economic growth. Especially say the coming decade when the emerging economies are in a particularly fast-growing phase and they need additional energy to do that. Now, at the moment we have 6.5 billion people on Earth. Now all those people, they want prosperity, so they want their economies to grow. So as China and India are in that particular spurt in economic growth, the world can expect accelerated demand growth for all types of energies the coming decades. This extraordinary demand reduction will probably mean that we also will have to do things differently, so different ways of transport. On the other hand, on the supply side, we have to do things differently as well, because say conventional oil and gas resources, they're not sufficient to keep pace with the demand growth. So we need new sources of supply, being it from renewables or from unconventional resources. However, these things always don't come that easy and normally also at higher costs. Now, all these things take time. You know, just to say, build new power station that can take anything between 5 and more years planning permission. So very much the decisions you make today really determines the energy system of the future. So sense of urgency and decision making is important if you want to change the energy system, say in 10, 20 years time. Because in the coming 10 years, the energy system is already decided in that sense. And actually you see that we still need more hydrocarbon fuels, so oil, gas, coal, to make that transition to a lower carbon world. Can we do it fast enough? I would say that in technological sense, yes, we could. But can we politically, can we actually build the required change fast enough? And that is very much the question. And I think politicians, but also the public at large, have to make some courageous decisions to change, and to change now if they really want that low carbon future fast.
Importance of energy conservation. In a scenario where India tries to accelerate its development process and cope with increasing energy demands, conservation and energy efficiency measures are to play a central role in energy policy. A national movement for energy conservation can significantly reduce the need for fresh investment in energy supply system in coming years. It is imperative that all our efforts are made to realize this potential. Conservation is an objective to which all the citizens in the country can contribute. Whether a household or a factory, a small shop or a large commercial building, a farmer or an office worker, every user and producer of energy can and must make this effort for his own benefit as well as that of the nation. Now in the end, let us summarize what we have learned in this lecture. Rapidly increasing energy prices, concern about resource depletion and climate change, and calls for national energy self-sufficiency have concentrated people's minds on the role energy plays in our lives. An energy-efficient system for commercial building such as offices and hotels is one that meets the primary needs and provides necessary indoor thermal climate and air quality while consuming the least amount of energy. Healthy competition in the energy sector will eventually bring down costs and assist capital formation. The primary goal of building control is to run the HVAC system to maintain occupants' thermal comfort and system energy efficiency. Physical and control system faults in HVAC system cause inefficient operation, increase energy use and reduce equipment life.